For as long as people have gazed at the night sky, we've dreamed of what's out there. Other worlds, other stars, even distant galaxies, the human imagination has always stretched far beyond our reach. But no matter how much we've dreamed, there's been one unshakable rule of the universe holding us back: the speed of light. According to Albert Einstein's theory of special relativity, nothing with mass can move faster than light. As something approaches that speed, the energy needed to keep accelerating it skyrockets toward infinity. It's like hitting an invisible wall built into the laws of physics. That's why even with our fastest spacecraft, like NASA's Parker Solar Probe, which can race through space at more than 430,000 miles per hour, would still take 6,300 years just to get to our nearest neighboring star system, Proxima Centauri, which is part of the Alpha Centauri star system. For human civilization, that's practically forever. If we want to become a truly interstellar species, we can't just go faster in the conventional sense. We need a completely new kind of solution, a cheat code built into the fabric of the universe itself. For decades, scientists and science fiction writers alike have imagined that solution: the warp drive. The idea isn't to shove a starship through space faster than light, which relativity says is impossible. Instead, it's about moving space itself. Imagine standing on a rug. You can't sprint across it at light speed, but if you pull the rug toward you in the front, while stretching it out behind you, you'll find yourself across the room without ever running. That's the warp drive concept. A starship would sit inside a bubble of flat space-time, while space contracts in front of it and expands behind. From the ship's point of view, nothing strange is happening. No crushing G-forces. No engine straining against impossible limits. The bubble itself moves, carrying the ship along on a wave of distorted space-time. This concept was first given mathematical form in 1994 by Mexican physicist Miguel Alcubierre. His Alcubierre drive showed that Einstein's equations didn't forbid the idea of warping space-time into a traveling bubble. The catch, however, was massive. It required negative energy density, a type of exotic matter with bizarre properties such as negative mass. Push it, and it would accelerate back toward you. The math demanded enormous amounts of this stuff, enough to form a shell around the warp bubble. The problem? We've never observed negative energy on any usable scale. While some quantum effects, like the Casimir effect, can produce tiny flickers of negative energy. However, trying to create stable large amounts needed for a warp drive seemed completely impossible. For nearly 30 years, that was the roadblock. The equations looked intriguing, but the fuel was essentially fantasy. But recently, that story has taken a dramatic turn. A team of researchers led by Fuchs and Christopher Helmerich, working with the think tank Applied Physics and in collaboration with the University of Alabama in Huntsville, revisited the problem. Their study, published in Classical and Quantum Gravity in 2024, asked a daring question: what if negative energy isn't actually necessary? Could space-time be manipulated using only the kind of positive, ordinary energy that makes up stars, planets, and people? The team built what they call the Warp Factory, a computational tool to simulate warp bubbles numerically. Using this framework, they designed new models of warp drives that satisfy all of physics' known energy conditions. In other words, the math works using real, ordinary matter and energy. What they found was astonishing. It's possible, at least in principle, to build a warp bubble that moves through space at a constant velocity without requiring exotic matter. Now, let's be clear. This new design is what's called subliminal, meaning slower than the speed of light. It doesn't let us jump across the galaxy in an instant. So you might wonder, what's the big deal about a warp drive that doesn't even break the cosmic speed limit? The answer is that for the first time, a warp drive has been shown to be physically possible within known science. The earlier Alcubierre model looked impressive, but was shackled by an impossible requirement. This new research shows that those shackles can be broken. Think of it like the early days of flight. Long before the Wright brothers built their flyer, mathematicians proved that lift could be generated with fixed-wing designs. That proof didn't get anyone across the Atlantic yet, but it changed human history by showing flight wasn't just a fantasy. Similarly, this new warp research is a proof of principle. It shows that the concept is not forbidden by physics. The road ahead is still unimaginably long, but the door is open. Of course, the challenges left are staggering. Even without exotic matter, the energy requirements are mind-boggling, far beyond anything humanity can currently produce. Engineers would also face questions no one yet knows how to answer. How do you form a warp bubble? How do you steer it? How do you safely turn it off at your destination without releasing catastrophic bursts of radiation? Some models even suggest that the bubble could sweep up interstellar dust and release it as a deadly particle beam at the front of the craft. And if future versions ever do reach faster than light speeds, there's the nightmare of causality violations, the possibility of messages, or even ships, effectively traveling back in time. So no, we are not building a warp drive starship in the next decade. Realistically, this is technology that might lie centuries ahead if it's ever achieved at all. But the importance of this breakthrough lies in possibility. For decades, warp drives sat in the impossible column of physics. Now, thanks to new models, they've been upgraded to monumentally difficult but conceivable. That shift might sound small, but in humanity's quest to reach the stars, it's monumental. This is the dawn of a new era in theoretical physics. The dream of warp travel is still just that, a dream. But for the first time in a generation, scientists have a new map to explore. Perhaps centuries from now, our descendants will look back at this moment as the beginning of the warp age. Until then, the journey continues. Not across space, but across the frontier of human imagination and discovery. I have left links in the description to point you towards these discoveries so that you can read the latest research for yourself. Thank you for watching. Please subscribe as your support helps this channel grow. See you in the next video.